Hello students, I am Amrita Kulkarni. Welcome back to Amrita's Blink English. Today we are going to see another chapter from class 7, that is data handling. In this chapter there are three main concepts: mean, mode and median. As well as we are also going to study the concept of range. Arithmetic mean. The most common representative value of a group of data is the arithmetic mean or the mean. The average or arithmetic mean or simply mean is defined as follows. Mean is equal to sum of all observations divided by number of observations. In this chapter, we are going to see three concepts, that is arithmetic mean, mode and medium. We are also going to see the concept of range. Now, before going ahead with these concepts, we'll quickly revise what do you mean by data and what are the types of data. Data is any information which you can represent in any mathematical form or equation form or in tabular form or in pictorial form, that is nothing but a data. Now, this data can be classified as group data as well as ungrouped data. Now, what do you mean by ungrouped data? Let's suppose you have any data is just in the form of values, which is not categorized, which is not classified, which is not subdivided into groups. That data is known as a ungrouped data. Now, let's take an example of your class. Let's say in your class there are 50 students. Now, let's say I am a class teacher of your class, and for certain purpose I need the height of all the students in the class. Now what I will do is, let's say I have your roll numbers, so I will just prepare a table. So in the first column I will just take down your roll numbers from, let's say, from 1 to 50, and in second column I will measure your height and I will take down, let's say, for roll number 1 there is Ramesh, his height is 5.5. On roll number 2 there is Suresh, his height is 5.2. Or let's say on roll number 3 there is a student named as Sunny, his height is, let's say, 4.5 feet, and so on. So basically what I will do is I will just enter the values roll number wise, height of all the students in the table. So what I will just have scattered values, that is roll number 1 this much, roll number 2 this much, roll number 3 this much. This kind of data is known as ungrouped data, where there are no groups, where there is no classification. But now let's say, in order to move ahead, now I have to take the heights of all the students in the school. Let's say in your school there are 10 division like yours, and each division has 50 students. So there will be entry of 500 students if I go ahead in the same way. And that huge data of 500 students I will not be able to process manually. So what I will do is I will just measure height of all the students. I will just tell respective height to, I will just tell the height to each student, and I will ask them to classify among themselves. Let's say group A will be, let's say I will call out the students whose height is below 4 feet, that is, and I will assign them into group A. Let's say 4 feet to 4.5 feet. Group B, 4.5 feet to 5 feet, that is group C. 5 feet to 5.5 feet, that is group D, and 5.5 feet and above is, let's say, group E. So now in this way what I will have is I will have 5 groups where on an average in that group the height will be similar. Now this kind of group data I will be able to utilize for certain purpose. Let's say I need to order uniforms to students, or I need to install some sports equipment in the school. So I can definitely take the average height of the students, and accordingly the installation can be done in the school. So basically whenever we have any huge data, so at that time, in order to process that data, what we have to do is we have to categorize them, we have to classify them in terms of groups, and once the classification is done, we will be able to use that data. Such kind of data is called as group data. Now we will move ahead with the next concept, that is arithmetic mean. The most common representative value of a group of data is arithmetic mean or mean. The average or arithmetic mean or simply mean is defined as follows. Mean is equal to sum of all observations divided by number of observations. So let's say in case of ungrouped data where just values are given. So how to calculate mean for ungrouped data is you just need to write down all the observations. You have to take their summations in the numerator and how many observations you have taken. So you have to divide by number of observations. Let's see an example. Ashish studies for 4 hours, 5 hours and 3 hours respectively on 3 consecutive days. How many hours does he study daily on an average? Now, Ashish studies for 4 hours on first day, 5 hours on second day and let's say 3 hours on third day. And we need to calculate how many hours he studies on an average. So now we are aware about the formula how to calculate the average. Average is nothing but arithmetic mean. So in order to calculate the average, we need to find out total number of hours he studied divided by number of days for which he studied, that is 4 plus 5 plus 3 in the numerator divided by 3 in the denominator. Now 4 plus 5 plus 3 is equal to 12. 12 divided by 3 is equal to 4. So we can say on an average he studied for 4 hours daily. Thus we can say Ashish studies for 4 hours daily on an average. Next example. A batsman scored the following number of runs in 6 innings. 36, 35, 50, 46, 60, 55. Calculate the mean runs scored by him in that inning. So we'll calculate total runs 36 plus 35 plus 50 plus 46 plus 60 plus 55, that is 282. We need to calculate mean runs scored by him. So mean runs, that is we need to calculate arithmetic mean. So to find out the mean, we need to find out the sum of all observation and we need to divide it by number of observations. So in this case, mean is equal to 282 divided by 6, that is 47. And hence we can say mean runs scored by him in that inning is 47. Find at least 5 numbers between 1 by 2 and 1 by 3. Find at least 5 numbers between 1 by 2 and 1 by 3. Now in the chapter of rational number, how we used to solve this problem is whenever we have asked to find out rational numbers between any two given rational numbers. So what we used to do is, let's say we need to solve this number by that particular method. Let's revise quickly. 1 by 2 and 1 by 3. So first step what we will do is we will find out the LCM of 2 and 3. LCM of 2 and 3 is 6. Now what we will do is we will find next or next to next multiple of 6. That is, let's say next multiple of 2 and next multiple of 6 is 12, or let's say on safer side we will find out one more multiple. We will consider one more multiple, that is 18. Now we will find out equivalent fraction of 1 by 2 and 1 by 3 to make their denominators 18, and then just by considering the numerator we will be able to find out rational numbers between 1 by 2 and 1 by 3. Now here we will solve the same problem just by using the concept of arithmetic mean. Now let's say this number is 1 by 2 and this number is 1 by 3 and both of them are on the number line. Now obviously whenever you find out their mean will obviously lie in between 1 by 3 and 1 by 2. Now in this case 1 by 3 is smaller and 1 by 2 is bigger number. So 1 by 3 is on the left side and 1 by 2 is on the right side. So in between 1 by 3 and 1 by 2 there will be the arithmetic mean. Arithmetic mean will lie in between them. So now we will use the same concept. So let's say first of all find out arithmetic mean of 1 by 3 and 1 by 2. Now how to find out mean is in the numerator summation of the observation divided by number of observation. So mean of 1 by 3 and 1 by 2 is equal to 1 by 3 plus 1 by 2 upon 2. Now 1 by 3 plus 1 by 2 in the numerator, LCM of 3 and 2 is 6. So in the numerator we have 3 plus 2 upon 6 whole divided by 2, that is 5 upon 6 whole divided by 2. Now denominator of denominator we need to multiply. So 6 into 2 is equal to 12. So we will have 5 by 6 upon 2 is equal to 5 upon 12. Hence we can say 1 by 3 is less than 5 by 12 is less than 1 by 2. Now let's say we will find out mean of 1 by 3 and 5 by 12. So mean of 1 by 3 and 5 by 12 is equal to 1 by 3 plus 5 by 12 whole divided by 2. So LCM of now 3 and 12 is equal to 12. So 3 4s are 12. Hence 1 into 4 is 4 by 12 plus 5 by 12 as it is whole divided by 2. Now 4 plus 5 is equal to 9. So 9 by 12 upon 2, which is equal to 9 upon 24. So now we will place this 1 by 3 is less than 9 by 24 is less than 5 by 12 is less than 1 by 2. Now let's say we'll find out mean of 9 by 24 and 5 by 12. So mean of 9 by 24 and 5 by 12 is equal to 9 by 24 plus 5 by 12 upon 2. Now LCM of 24 and 12 is equal to 24. 9 as it is, 12 2s are 24, hence 5 2s are 10. So 9 plus 10 upon 24 whole divided by 2, that is 9 plus 10 is equal to 19. 19 by 24 upon 2, which is equal to 19 upon 48. So the order will be 1 by 3 is less than 9 by 24 is less than 19 by 48 is less than 5 by 12 is less than 1 by 2. Now we'll find out mean of 5 by 12 and 1 by 2. You can also find out mean of 19 by 48 and 5 by 12, or any two numbers you can consider, and it's just that you need to place them at the correct place. Now we'll find out mean of 5 by 12 and 1 by 2. Now mean of 5 by 12 and 1 by 2 is equal to 5 by 12 plus 1 by 2 upon 2. Now LCM of 12 and 2 is equal to 12. So 5 by 12 as it is, 2 6 are 12, hence 1 into 6 is equal to 6. So 1 by 2 is equal to 6 by 12. So 5 by plus 6 upon 12 whole divided by 2, that is 11 by 12 divided by 2, hence it is equal to 11 by 24, and hence we'll get the order as 1 by 3 is less than 9 by 24 is less than 19 by 48 is less than 5 by 12 is less than 11 by 24 is less than 1 by 2. And we need to find out one more number, hence we'll find out mean of 11 by 24 and 1 by 2. So mean of 11 by 24 and 1 by 2 is equal to 11 by 24 plus 1 by 2 whole divided by 2, that is 11 plus 12 upon 24 whole divided by 2. Now why 12? 2 into 12 is equal to 24, hence 1 into 12 in the numerator. So we have 11 plus 12 upon 24 whole divided by 2, that is 23 by 24 whole divided by 2, which is equal to 23 upon 48. Hence we have 1 by 3 is less than 9 by 24 is less than 19 by 48 is less than 5 by 12 is less than 11 by 24 is less than 23 by 48 is less than 1 by 2. We'll see example 4. The ages in years of 10 teachers of a school are 32, 41, 28, 54, 35, 26, 23, 33, 38 and 40. What is the age of the oldest teacher and that of the youngest teacher? What is the range of the ages of the teachers? What is the mean age of these teachers? Now arranging the ages in ascending order, we get 23, 26, 28, 32, 33, 35, 38, 40, 41, 54. So here what we have done is we have arranged all the data in the ascending order. Now commonly what mistakes students generally make is whenever there are repeated values, so students avoid writing those repeated values. But if there are repeated values, you have to write them as it is. So let's say if 33 is repeated, then our order would have been 23, 26, 28, 32, 33, once again 33 and then 35 and so on. So if you skip writing these repeated values, then your other operations, that is calculation of mode, calculation of median, will get wrong. That's why never skip the repeated values if there are any. So now what is the age of the oldest teacher? Once we arrange the data in ascending order, we can easily find out. So age of oldest teacher is 54 years and age of youngest teacher is 23 years. Now what is the range of the data? Now we know that range of the data is highest value minus lowest value, that is 54 minus 23, which is equal to 31 years. And what is the mean age of these teachers? How to calculate mean is summation of all the observations divided by total number of observations. So mean age of the teachers is 23 plus 26 plus 28 plus 32 plus 33 plus 35 plus 38 plus 40 plus 41 plus 54 whole divided by 10, because there are 10 observations. So 350 divided by 10, 0 cancel. So we have 35. Hence we can say that mean age is equal to 35 years. Mode. The mode of a set of observations is the observation that occurs the most often. We have just seen the concept of arithmetic mean. Now the next concept is mode. Now what do you mean by mode? Is the observation which occurs most of the time. So we need to calculate all the repeated values and the observation which occurs highest number of times, that observation is called as a mode. Let's see example number 5. Find the mode of the given set of numbers 1, 1, 2, 4, 3, 2, 1, 2, 2, 4. Now, in order to find out the mode, what we need to do is we need to arrange the numbers with the same values together, so that we'll be able to find out the frequency. So, 1 has occurred 3 times. Now, 2 has occurred 4 times in the data. 3 has occurred only once and 4 has occurred 2 times. So, we can say that as 2 has occurred 4 times, 2 is having maximum frequency which is equal to 4, and hence 2 is the mode of this data. We'll start with example 6. Following are the margins of victory in the football match of a league. Find the mode of this data. 1, 3, 2, 5, 1, 4, 6, 2, 5, 2, 2, 2, 4, 1, 2, 3, 1, 1, 2, 3, 2, 6, 4, 3, 2, 1, 1, 4, 2, 1, 5, 3, 3, 2, 3, 2, 4, 2, 1, 2. Now we need to find out the mode of the data. Now what is mode? Mode is the value mode is the observation which occurs maximum number of times. So we need to find out the frequency of each observation, that is each value is repeated how many number of times, that we need to find out. So to do the same, we will follow the method of tally marks. So we'll create the table, margins of victory, then tally bars, and then number of matches. So let's say 1 has occurred 9 times. We'll just cross verify. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 9 number of matches are 9. Then 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So 2 is 14 times. 3, 1, 2, 3, 4, 5, 6, 7. So 3 is 7 times. Then 4, 1, 2, 3, 4, 5. So 4 is 5 times. Then 5, 1, 2 and 3. 5 is 3 times. Then 6 is just 2 times. So if you observe 1 for margins of victory for 1, we have number of matches 9. For 2 it is 14. For 3 it is 7. For 4 it's 5. For 5 it's 3. For 6 it's 2. So maximum number of matches are 14, which are for 2. Hence we can say 2 is the mode, since 2 has occurred highest number of times. Find the mode of 2, 6, 5, 3, 0, 3, 4, 3, 2, 4, 5, 2 and 4. Now we'll create the table. First column observation, second column tally bars, third column number of matches. So let's say for 0 has occurred just once. So 0, tally bar 1, number of matches 1. Now there is no entry of 1, so we need not write 1. Then 2, 1, 2 and 3. So for 2 it is 3. Then 3, 1, 2 and 3. So for 3 also number of matches are 3. 4, 1, 2 and 3. For 4 also it is 3. 5, 1 and 2. 5 has occurred 2 times and 6 has occurred just 1 time. Now here if you observe, maximum number of matches are 3, but 2 also has occurred 3 times, 3 has also occurred 3 times and 4 has also occurred 3 times. So maximum number of matches 3. Hence we can say that there are 3 modes, 2, 3 and 4. All 3 entries are modes of the data, and such data where there are more than one mode exists, such data is called as multimodal data. So multimodal data has more than one modes. We'll see example number 8. Find the mode of 2, 14, 16, 12, 14, 14, 16, 14, 10, 14, 18 and 14. तर आपण पाहूया 2 has occurred just one time. 10, so 10 again one time. Then we have 12, so 1 again only one time. 14, 1, 2, 3, 4, 5 and 6, so 6 times. Then we have 16, 1 and 2, so 16 has occurred 2 times. And then 18 has occurred 1 time. Times is maximum number of matches are 6. So 14 is the mode, since 14 has occurred highest number of times. 2 has occurred 1 time, 10 has occurred 1 time, 12 has occurred 1 time, 14 has occurred 6 times, 16 has occurred 2 times, 18 has occurred 1 time. Hence 6 is the maximum number of matches, hence 14 is the mode of the data. We'll see example number 9. Find the mode of the numbers 2, 2, 2, 3, 3, 4, 5, 5, 5, 6, 6 and 8. Now here just by observation we can say that 2 has occurred 3 times and 5 also has occurred 3 times. So we can say that 2 is the mode of the data as well as 5 is the mode of the data. That's why 2 and 5 both occurs 3 times. Hence both 2 and 5 are mode of the data. We'll move to example number 10. Find the mode of the following data: 12, 14, 12, 16, 15, 13, 14, 18, 19, 12, 14, 15, 16, 15, 16, 16, 15, 17, 13, 16, 16, 15, 15, 13, 15, 17, 15, 14, 15, 13, 15 and 14. So we'll create the table. Margins of victory, tally bars and number of matches. 12, 1, 2, 3, for 12 it's 3, then 13, 1, 2, 3 and 4. For 14, 1, 2, 3, 4 and 5. For 15, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. For 16, 1, 2, 3, 4, 5, 6, 6. For 17, 1, 2. For 18 is just 1. For 19, 1. So maximum number of matches are 10. Hence 15 is the mode of the data. We'll move to example number 11. Heights in centimeter of 25 children are given below: 168, 165, 163, 160, 163, 161, 162, 164, 163, 162, 164, 163, 160, 163, 160, 165, 163, 162, 163, 164, 163, 160, 165, 163 and 162. What is the mode of their heights? What do you understand by mode here? Now here there are two questions. We need to find out the mode of the data as well as we need to find out the inference from the data. Let's create the table. Heights in centimeter, tally bars, number of matches. 160, 1, 2, 3 and 4. 161, 1 is just 1. 162, 1, 2, 3, 4, only 4. 163, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 164, 1, 2, 3, 165, 1, 2, 3, 3, 168, 1, only 1. Now here carefully we have to make the tally bars for each entry. Now here if we observe, maximum number of matches are 9, that is 163. आता इथे maximum number of matches आहेत 9 163 साठी. Hence we can say 163 is the mode of this data. So most of the children have the height 163 centimeter. So the conclusion is maximum students in the class have height as 163 centimeter. In a given data arranged in ascending or descending order, the median gives us the middle observation. Whenever you arrange the data in ascending or descending order, the middlemost value is called as median. Median. In a given data arranged in ascending or descending order, the median gives middle observation. We'll see example number 12. Find the median of the data 24, 36, 46, 17, 18, 25, 35. We arrange the data in ascending order. We get 17, 18, 24, 25, 35, 36 and 46. So now there are 7 values. So if we need to find out the middle value, then let's say we'll scratch these 3 and we'll scratch these 3 and middlemost value will be 25. Hence we can say 25 is the middle observation, that is 25 is the median of the data. Now next concept is bar graphs. Bar graph is very simple type of graphs, a very simple type of charts. It's very easy to understand, it's very to read the data. It is the way in which the given data, given mathematical data is represented in pictorial form, that is called as a graph. 200 students of 6th and 7th classes were asked to name their favorite color so as to decide upon what should be the color of the school building. The results are shown in the following table. Represent the given data on a bar graph. Favorite color, there is a table given, favorite color and number of students. So red 43, green 19, blue 55, yellow 49, orange 34. Answer the following questions with the help of bar graph. Which is the most preferred color and which is least preferred? How many colors are there in all and what are they? How many colors are there in all and what are they? Now we will draw the bar graph from this data. In order to draw the graph, we need x-axis and y-axis. So on x-axis, we will plot the colors, that is red, green, blue, yellow and orange, and on y-axis we will place number of students. Now there are 43, 19, 55, 49 and 34 students respectively. So we can take a scale of 1 unit is equal to 10 students, and then accordingly we can draw the graph. So 43 students for red, 19 for green, 55 for blue, 49 for yellow and 34 for orange. Now based on these graphs, we will find out the answer. Now here the graph which is the column which is having the highest height will be most preferred, and the column which is having the lowest height is obviously least preferred color. So we can say blue is preferred by most of the students and green is preferred by least number of students. How many colors are there in all? Now we have 5 columns on x-axis, hence there are 5 colors, that is red, green, blue, yellow and orange. Example number 14. Following data gives total marks out of 600 obtained by 6 children of a particular class. Represent the data on a bar graph. Students and their marks obtained. Ajay 450, Bali 500, Deepti 300, Fayaz 360, Gitika 400, Hari 540. Now here on x-axis we will place names of the students and on y-axis we will place their marks. Now if you observe the data, what scale we need to take is 1 unit is equal to 100 marks. So we'll put the entries. Now Ajay, first for Ajay it is 450, for Bali 500, for Deepti 300, for Fayaz 360, for Gitika 400 and for Hari 540. Here you can also take the scale of 1 unit is equal to 50 marks. but in that case your graph will be a bit longer. Example 15. Following two collections of data giving the average daily hours of sunshine in two cities, Aberdeen and Margate, for all the 12 months of the year. These cities are near the South Pole and hence have only few hours of sunshine each day. Draw a double bar graph from the data. In Margate, so there are entries January, February, March, April, May, June, July, August, September, October, November, December. Average of hours of sunshine, that is 2, 3, 1 by 4, 4, 4, 7, 3 by 4, 8, 7, 1 by 2, 7, 6, 1 by 4, 6, 4 and 2. And in Aberdeen, average hours of sunshine are 1, 1 by 2, 3, 3, 3 by 2, 3, 1 by 2, 6, 5, 1 by 2, 6, 1 by 2, 5, 1 by 2, 5, 4, 1 by 2, 4, 3 and 1, 3 by 4. Now here there are two cities and there are 12 months. So in order to draw this graph, we need to take two different cities and hence the graph will be double bar graph. Now if you observe the data, so what scale I have taken? 1 unit is equal to 1 hour of sunshine. So on y-axis we have 0, 1, 2, 3, 4, 5 and up to let's say 8 or 9. So now what you need to do is you need to represent whatever is the data for Margate with different color, or if you are drawing with pencil you can just shade it, and if you are and for Aberdeen you can give dots or some different pattern. Here I am drawing on computer, so I have just given different colors. So green color is for Margate and sky blue color is for Aberdeen. So now we'll just first of all place all the entries month wise. So January for both the cities. So January 2 and then 1 by 2, then February 3, 1 by 4 and then 3, then for March 4, 3, 1 by 2, for April 4 and 6, for May 7, 3 by 4 and 5, 1 by 2 and so on. Example 16. A mathematics teacher wants to see whether the new technique of teaching she applied after quarterly test was effective or not. She takes the scores of 5 weakest children in the quarterly test out of 25 and in the half yearly test out of 25. Students Ashish, Arun, Kavish, Maya and Rita. So quarterly 10, 15, 12, 20 and 9. Half yearly 15, 18, 16, 21 and 15. So here you need to draw the graph. So on x-axis again this is a double bar graph. So on x-axis we will place the number of students, and half yearly we will indicate with different pattern and quarterly will indicate with different pattern. Here I have indicated quarterly with green color and half yearly with sky blue color. And on y-axis I have taken the scale of 1 unit is equal to 5 marks. So for Ashish it is 10 and 15, for Arun it is 15 and 18, for Kavish it is 12 and 16, for Maya it is 12 and 21, for Rita it is 9 and 15. Thank you for watching the complete video. If you have any queries, do let me know in the comment box. Do subscribe the channel and hit the bell icon. Thank you. If you like the video, do share it with your friends. Thank you.